we have on stage is doing something very interesting. Danny has a track record of leading AI initiatives at companies like Amazon and Microsoft and Uber. And recently he's joined Unity Technologies, where he's basically looking at the intersection of VR and AR and AI and how you use like training models in a virtual environment so that your robot can already be trained before he gets on stage. So with that, I'd like to introduce Danny, and he can share his thoughts in terms of what he's doing. Thank you, Danny.
Thank you. I need the clicker. Here we go. Oh. Wrong slide. Here we go. No. Okay. Okay, thank you. Super excited being here. When I got the invitation, my first response was to respond in an email saying, I'm not from MIT, you made a mistake. So I'm here anyway. So that's, I'm pretty happy being in a room with so many smart people. I'm going to talk a bit about AI and machine learning in gaming, especially you know, in a future where we're not going to work. We can still game. Yeah, okay. Let me go back a bit because I want to give you a context. This is not just, when I talk about this stuff here, I'm actually not coming from a gaming world. Yeah? I'm coming, before joining Unity early this year, I was head of machine learning at Uber, and I love Uber. Uber believes in machine learning. Uber is a machine learning driven organization, or nowadays we dare to call it AI, but it's machine learning. At Uber, I built a machine learning platform so we could get machine learning into every corner of the company, which is basically three big areas. It's the core business of drivers, riders, and trips. There's like 8 machine learning models in play in the Uber Eats app alone. You also, in November, got the update that would guess 3 probable destinations when you open the Uber app, so you don't have to remember addresses any longer. That's machine learning too. Yeah? Uber is also doing machine learning in the mapping space, using a lot of computer vision, recognizing street signs and building maps automatically. It's much more efficient than having thousands of contractors sitting and building those maps. It's also, the last thing, what is it? It's the self-driving cars, yeah. Machine learning, lots of machine learning too. Yeah? So it was wonderful to work on all those 3 things. Before joining Uber, I was GM for machine learning at Amazon, ran the Elastic machine learning team, which is the same idea, bring machine learning into every corner of Amazon. Yeah? So it was like, I believe, almost 100 teams using EML, Elastic machine learning, to do all kinds of stuff like predicting your shoe sizes and all that stuff, and recommendation, etc., fraud detection, and so on. It was so successful that we actually built a public version of it, and I launched that on AWS as a public machine learning service, typical Amazon thinking, which is like, if our secret sauce is so good for us, we'll make it available to the public and make money a second time. Yeah. Before that, I was many years at Microsoft doing machine learning. I was at IBM Research, and in between IBM, I did work in 2 startups trying to build voice-enabled virtual assistants. That was tough with that speech recognition that time. Okay, let's get back to Unity. Interesting part about Unity is that we got 16 billion downloads of our gaming platform last year. That's a lot. It's more than any other piece of software in the App Store. Yeah? We had 2.6 million unique devices where the Unity engine is installed. The engine is crucial for developing games, but it's also crucial for connecting back to the back end and do gaming analytics, doing monetization, etc. Over 700 million monthly active users playing things like Pokemon Go or Super Mario or many, many other mobile games. We've got 38% of the market share in mobile games, and yet most people never heard about us. 50% give and take on the console market, Xbox, PlayStation, and I believe 60–70% of the VR market is actually of apps are developed on Unity. Yeah? So let me show you something here, which is why it's such a good idea to develop your games on Unity, because we support 30 platforms. Yeah? We also give you development tools for creating these games. And you can also buy a medieval village for $50 and develop your own game there, and you can buy the characters. So it's an entire ecosystem for gaming, yeah? So when you have a thing like that, you can take it a step further, yeah? And I'm going to show you a video here. What I show you here is a video, but you can actually download this with the Unity platform to a PC. It has to be a high-end PC, like an NVIDIA GTX 980 graphics card. And this thing will render in real time 30 frames per second. Yeah? Yeah. There, you're able to move the camera, you're able to have multiple shots, you're able to move everything around because all the models of the characters are in there, the interior is in there, and actually when they walk out of this building, the exterior is there. And you can as a viewer, or you can be your own movie director in real time and move around, yeah? And you can imagine how you could take on a pair of goggles and get in there and be a part of that digital experience, yeah? So this is not a fixed movie in the sense that a director already, held the camera in a certain position and that's it, yeah? This has the ability to become a personal experience, yeah? Now, unfortunately, this is 10 minutes long. We don't have time for that. So let me jump out and talk a bit about this. Before machine learning, which is really most of what we see today, yeah? We have these incredible programmers that write all this deterministic code because they figured everything out. They have a spec, they know everything, yeah? Even 99.9% of all games are hardwired like that. Most software out there is hardwired like that, yeah? And it's what I call a Newtonian thinking. It's really several hundred years old. And it's this idea that I can compute everything past, present, and future, which we all know you cannot, yeah? So when it comes to a lot of software, whether that's business or gaming, it's hardwired, yeah? The characters you just saw, their movements, everything they do is hardwired, yeah? You can look around, you can move camera up and down, but you can't really interact with them, yeah? Because they're just programmed to walk out of that building, yeah? So that's why we need to start thinking differently. We start to have learners, we need to have data, we need to build models that take new data and make predictions, yeah? We need to think more like Heisenberg. This is about probabilities, it's about distributions of those probabilities, and then with this ability to learn and with this ability to understand that the world is not deterministic, we can start creating more believable interactions, yeah? I also studied John Boyd, US Air Force, studied air combat in the Korean War. He realized that pilots, they operate in the OODA loop, that they observe what's going on around them, they orient themselves in the 3D, they decide to do something and they act upon it. Fire the missile, make a loop, get out of there, whatever. He found that it does not matter if your decision is right every time. What really matters is how fast you move through the loop. Yeah? If you move through the loop 2.1 times faster than your opponent, your enemy, yeah? Then if you make a mistake, you can actually fix it, yeah? I realized studying John Boyd that this is also, what happens in agile software development, in agile product development, in a lot of worlds. I read a paper by John Boyd and whoops, up came Heisenberg. He got Gödel in there too. He observed this idea that any model of reality is incomplete. And he also have, Boltzmann in there. If you look at this, you have to take machine learning further than just, I can make predictions, yeah? And you need to make an iterative thing, yeah? And this is actually what's happening around us. Let me take the slot machines in Las Vegas for a moment here. And see how you can use this OODA loop to start figuring out which slot machine is the best one, yeah? You have a bunch of slot machines, they give different returns. Your objective is to maximize winnings, and what you do is that you go through this loop where you exploit and explore. Yeah? Your exploitation is basically based on the knowledge you have. You try to play the machine that gives you the most payback. You play that machine the most, but you don't really know if you're missing some other machines there that may be given even better outputs, yeah, or returns. Yeah? So think about the OODA loop. You move through this loop. You constantly try to refine the model of the world, and you try to understand which slot machine is the best for me to use. Yeah? That's known as a bandit algorithm. There are some further developments around that, which we call it reinforcement learning, where we look at the actions, pulling these, and the rewards we get back. Yeah? But keep this in mind, machine learning, predictions, through the OODA loop, where we keep improving the model, and then into the world of exploitation and exploration. Let's give an example of this where it's so important. If you make recommendations, whether it's Netflix or Amazon, if we make the kind of the perfect recommendation, it becomes a bit like the fake news we talk about in Facebook, and where you get too much of the stuff that is just so tailored to you. Yeah? You get all the same sci-fi books every time you go to Amazon. Yeah? And you see it when you have shopped. I shopped for a pair of shoes for my wife, and suddenly I saw shoes for 3 weeks on the internet. Yeah? That's so bad, yeah? That's bad machine learning. That's just prediction, yeah? Oh, you like shoes. I'm going to keep throwing shoes at you. You have to have the exploration in there, yeah? Without the exploration, the system is not going to learn anything new about you, yeah? So that's why Netflix dump tons of stuff in there. It's like the Netflix recommendation is not what it used to be, where it was trying to narrow you. It's like there's all kinds of stuff in there, yeah? You go to Amazon, there's all kinds of stuff in there. Constantly probing, yeah? So let's see this in practice, yeah? And I'm going to show you this little example here. It's a blue chicken or purple chicken crossing the road, trying to gather some bricks that are the rewards, yeah? And if you hit a car, you're in trouble, and every time you move, you also pay a little penalty, yeah? So you see, this chicken is not good at it. It's randomly, in the OODA loop right now, it's pure exploration, yeah? It has no idea. It's moving, look, it's actually moving the wrong way most of the time, yeah? Yeah? But after burning, a kilowatt, it starts getting better, yeah? This is a generic reinforcement. Oh, there it hit a car, yeah? Not good. And it made it, yeah? So you see, it's a generic reinforcement learning algorithm that we use to train this chicken to cross the road, yeah? And you can imagine coding this in C, and you can probably do that. It's going to take a little while. Instead, here we let the computer work for some hours. Let's see what happens after 12 hours. What is that, 12 kilowatts now? It's getting really good at it, yeah? Nobody told it what to do. Yeah? Now, it started out being pure exploration, and now the exploration is sort of shrinking and becomes more exploitation because it kind of knows how to do this. Yeah? Yeah? Relevant for games, because now I don't have to program my NPC, my non-player character. But also when you sell books, when you drive cars, when you try to get people to watch movies, it's the same idea. Yeah? Let's move into, I worked with Professor Jeff Snyder at Carnegie Mellon. He's one of the leaders of Uber's self-driving car project in Pittsburgh. And he showed me, he had done this research here of a mechanical snake learning to climb a wall, basically having the ability to move and have sensors. And then there's a poor student sitting and watching this thing and giving it a reward every time it gets to the other side of that barrier, yeah? So can you imagine if I was going to code that thing in some parallel programming language have all these motors to operate. You know, I have to be like a Walt Disney artist because I have to study snakes, I have to figure out how they actually work, and I have to implement it, and it's going to be buggy, and then it's going to meet a situation I've never seen before, and then it's going to get stuck, that kind of stuff. Yeah. This thing learns by wiggling, by exploring, and learns and gets better and better. And if you notice, the barrier is going up. Yeah? So it reuses the learning from one level to the next, just like when the kids go to first grade and second grade and third grade and so forth. Yeah? So I was always very fascinated with this video because it's sort of back into the real world. Yeah? And it eventually can get quality really high. Now, this is a semester-long project. You can see why. Yeah. Yeah. Okay. So let's go back into the virtual world. Yeah. So we have a Japanese Unity developer did this, and he's utilizing the Unity as a physics engine with gravity, friction, inertia, everything. You can see her hair sort of hanging down, and he's basically giving her. You can do seven movements. And he's using the same algorithms as we did for the chicken. And in this case, she's trying to figure out how to swing. Yeah? And you see the reward is going up after 30 minutes of training. It starts figuring out what the patterns of movements should be. Yeah? And we give it 5 hours on that NVIDIA GPU. And what happens now? I haven't done this. I would actually love to see how a real gymnast is doing this, yeah? Because there's no programmer here, yeah? It's just a standard deep Q reinforcement learning algorithm, yeah? 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 Yeah. So watch out, game programmers, you know, or game developers, yeah? No, just kidding. I'm going to show you this one quickly too. This is the Deep Q one. There's one fascinating thing in this one. This is a breakaway game. That when I show you this ability to learn to play games, just to think about it, it's the same as being in a game, playing a game, and there are other actors in the game that are computer-driven actors, and they learn how to interact with you. Yeah, that's the analogy. So in this one here is very interesting. Because, I don't know if you ever played this game. Again, you see a pattern here. The first attempt is terrible, 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 yeah? It's just exploring. It has no idea. It's completely random, yeah? But over time, it figures out how to play this game pretty solidly. And again, you know, it always takes 1 or 2 hours. I don't know why. In this, anyone who played this game can see this is going pretty well. But if you have really played this game, you know there's a secret in this game. What do you want to do? You want to get up behind, yeah? So this is pretty good, but you really want to get up behind. Getting up behind is what we call short-term value versus long-term value, yeah? You need to invest short-term. And look what this thing does, I say thing, does after 4 hours. It figures out that it should invest in getting up behind and bang, there we go. Yeah? Isn't that interesting? So can you imagine, you know, the next, I don't know, book-selling algorithm at Amazon trying to figure out that I shouldn't sell you 2 $5 books right now because I'm going to sell you a $30 book tomorrow. Yeah? I'm just going to wait. Yeah? That's really crucial. Yeah? So why is this possible? Well, because it mixes up. You saw the snake. You saw the girl on the swing. Yeah, there's a physics engine in there. There's a lot of stuff in there that ties, that creates sort of a virtual environment that is also applicable to the real world. Yeah, and all this stuff is really happening now because we have all the tools. We have the compute power, we have deep learning, we have reinforcement learning, a lot of technologies coming together, yeah? And it really opens up the possibilities for doing things in brand new ways, like, do you really need to drive around with real cars on real streets to teach a car to drive? Maybe I can get a couple of billion miles in first, yeah, in a virtual world, and then when I'm done, I bring it out in the real world and we do the final little bit of learning out there, yeah? Anyway, that was unfortunately the end of it. Thank you.